Hello and welcome back to another video. In this problem, we're asked to prove that the equation has at least one real root and to use the calculator to find an interval of length 0.01 that contains a root. So rearranging this equation, we get cosine of x minus x cubed equals 0. We're going to call this f of x, right? We're saying f of x equals 0 at one point. And the way we're going to do this is not by actually finding the root, but by finding the values that are going to allow us to use the intermediate value theorem to find the root in an interval, right? So cosine of x is continuous over all real numbers. X cubed is continuous over all real numbers. We know that from theorem 7. And by theorem 4, we can say that their subtraction is continuous, therefore, by all real numbers. So using the fact that this function is continuous everywhere, we can say by the intermediate value theorem, if we have an interval where f of a is less than 0 and f of b is greater than 0, then there is a root on the interval from a to b, right? And we could also flip this. If f of a is greater than 0 and f of b is less than 0, it's the same thing. And what this is basically saying is, if we start here at a and here at b, and we go from positive to negative, there's no way to get from positive to negative without crossing the x-axis at some point, without having some jump or skip or something, which means it wouldn't be continuous. So here, we just need to find an interval that has a positive value on one end and a negative value at the other, and we know that somewhere in between there's going to be a 0. So we can try f of 0 is equal to cosine of 0 minus 0 cubed equals 1 minus 0, which equals 1. If we try f of 1, that's equal to cosine of 1 minus 1 cubed. This can be a little bit harder to calculate. This is just plugging into your calculator, negative 0.45. And therefore, f of 0 is greater than 0, f of 1 is less than 0. There is a root on the interval from 0 to 1, right? And so if we're imagining this, right, we have the interval from 0 to 1. At some point here, we are going to have a root, right? Because here we're positive and here we're negative. In part B, we're asked to use the calculator to find an interval of length 0.01 that contains a root. So we need to shorten this interval so it still has a positive and negative side, but it has a length of 0.1. So the easiest way to do this is to start cutting it in half. So we have 0.5. F of 0.5 is equal to cosine of 0.5 minus 0.5 cubed, and that's equal to 0.75 roughly. So that's positive. And so our new shorter interval with a positive and negative end is between 0.5 and 1. So split it in half a second time. 0.75 is cosine of 0.75 minus 0.75 cubed is equal to 0.31. So still positive at 0.75. The next thing we can try is 0.85. That's cosine of 0.85 minus 0.85 cubed. That is equal to 0.045, getting very close. But if we look at 0.85, that is still positive. So our now range is between 0.85 and 1. So we can try 0.9. That's cosine of 0.9 minus 0.9 cubed is going to be equal to negative 0.1. So if we do 0.9, that's negative, right? And we're sort of running out of space here, so I will do it over here. We know that 0.85, the value of the function, is positive, and at 0.9, it's negative. And it's going to be, it looks like a little bit closer to 0.5 because its value is closer to 0. So let's try 0.86. F of 0.86 is going to be cosine of 0.86 minus 0.86 cubed. This is 0.016, so it's still positive. We want an interval of 0.01, so let's go 0.01 over. This is cosine of 0.87 minus 0.87 cubed, and this is negative 0.0136. So 0.86 is positive, 0.87 is negative. Therefore, we know that if the function goes from positive to negative over this interval, 0.86 to 0.87, at some point in this interval, the function has a root. That's our answer to A and B.